Hello everyone, welcome back to my channel FRM Unplugged. Today we will be doing certain numericals from chapter 5 of book 2, which is sample moments. This chapter is basically content heavy. There are far too many theoretical constructs, there are numerical problems, and there are around 11 to 12 LOSs, though about 3 to 4 LOS have numericals, rest all are theoretical. So we may need a further sequel to today's class. So we may have a part 2 or part 3 or even part 4 of this chapter. So today we will be exclusively dealing in skewness and kurtosis, right? So we can straight away go to the LOS 8. So LOS 8 talks about estimation and interpreting the skewness and kurtosis. So we may be asked to find out the skewness, or we may be given some data and we have to take a stance whether it is, whether the distribution is spiked or it is skewed. Like that we have to take a stance, right? So the first question is, a bond has a probability of default of 5%, okay? Which is the nearest respectively to the skew and kurtosis. So in these kind of problems, since we will have lesser time, and since these numbers are quite different even for skewness, so even if we get the skewness correct, we can assume that the kurtosis will be correct, because had there been two similar skewness answers, then we would have been forced to calculate the kurtosis. So fine, let us see what it is saying. So it is basically saying that the probability of default is 5%, okay? So basically this is a Bernoulli distribution, right? Bernoulli distribution as in there are only two possible outcomes, either it will default or not default. So here P is equal to 0.5, Q is equal to 0.95, and N is equal to 1, because there is only one bond, okay? So for skewness, what do we need to find out? We first need to find out the mean, right? So mean is what? NP is mean. So remember the binomial distribution, NP is the mean, is equal to 0.5, and NPQ is equal to the standard deviation. Sorry, NPQ is the variance, which is 0.05. This is 0.05. So 0.05 into 0.95 is 0.05 into 0.95 is how much? 0.0475, right? 0.0475. Now what we know? So the third central moment is the skewness. The standardized third central moment is skewness, which is expectation of x minus expectation of x whole cube by sigma square to the power 3 by 2, right? Because sigma cube is, we can write it this way, and sigma square we have already found out from here. So we will straight away calculate the third central moment. So what is x? X is 1 and another is 0. So 1 minus 0.05 to the power 3 into 0.05 plus 0 minus 0.95 to the power 3 into 0.95. This is the third central moment, okay? So whatever we find this value here, and we divide it by sigma square, we have already got here 0.0475. So 0.0475 to the power 3 by 2. So we have the y to the power x function in our BA2 plus calculator. We just need to put 0.0475 y by x, y to the power x, then write 1.5. We will get the denominator and do the maths and then find out. So that's how we calculate the skewness. And like I mentioned, since skewness is distinct, whatever is the answer, just select that. No need to calculate the kurtosis. Now let us go to the next question. Here we are given one probability mass function and we are required to find the kurtosis. So here just first let us write down the equation here. I mean the formula for kurtosis by sigma to the power 4, right? So first step is, step 1 is we will calculate mu. Mu is equal to 10% into minus 2 plus 20% into minus 1 plus 40% into 0 plus 20% into 1 plus 10% into 2. This is the mean. We got the mean. Now we will also need the variance. So for variance, what we will do? So we have now the mean. Now for variance, minus 2 minus whatever is the mean square into 10% plus minus 1 minus mu square into 20%, like that. So we will get here sigma square. Two things we have got. So two things we have got. Now what we will do is expectation of now x minus expectation of x to the power. So we will find out the fourth central node. This is the third step. What's the fourth central node? Is minus 2 minus mu to the power 4 into 10% plus minus 1 minus mu to the power 4 into 20%, like that. We will find out. Now the last step is step 3 result by this result 2 to the power 2. This is the final answer. This is how we can see. Obviously here there is you will be given maybe certain values, like for example sigma square we may be given, so we need not calculate all, otherwise this is not a 2-minute or 3-minute kind of, it may stretch to 3.5-4 minutes kind of a thing. And it is preferable we do this at the last. We don't do it initially because these are kind of calculation intensive. But in case we are not sure about few of the questions which we have no idea on, we just do a random guessing and come to these questions where you have more probability of solving. That is where these questions are important. Now let us look into the third question. Mary Noel, who is an FRM, is tasked with analyzing the returns of two different A and B. She finds that two assets have the same mean variance and skewness, but A has a higher kurtosis. So then, here, just try to visualize the problem, the graph. Okay, so it should be like this somewhat. So this is A, this is B. Okay. So A's graph is, since A has higher kurtosis, kurtosis means the degree of peakedness, and this has less peakedness, right? B, this is B. Now the area, since the mean, variance, skewness, everything is same also, and we know that the area of the normal under the normal curve is 1, right? Standard norm. So what will happen is, in this case, in A, the tail is going to be fat because this area and this area are the same. So here the tail is not very fat, this tail, but here this tail is fat tail. So there is a substantial probability of the tail events happening. In this B case, the probability of a tail event, which is extreme losses kind of events, is very less. So in normal distribution, here is, these are the probabilities, right? And these are the values of the random variable. So here if you see, this is very small, this probability, but here, since the area is the same and since this is more peaked, this tail is supposed to be fatter, and fat tail means here probability is more than what is here. So asset A is riskier. Why is it riskier? Because there are more chances of loss, more probability of loss in asset A. Now let us go to the fourth problem, right? So it is saying that W is a distributed normally, okay? So here a few things we have to keep in mind, that excess kurtosis of a normal distribution is 0, which means the kurtosis is 3. Excess kurtosis is whatever is the actual kurtosis minus 3. That is the excess kurtosis. So what is the kurtosis? We have to find out. So first let us find the fourth central moment, which is expectation of W minus expectation of W to the power 4 by sigma to the power 4. This is how much? This is the kurtosis, which is 3, right? This is a normal distribution. So this is what? This implies expectation of W minus 0 to the power 4 by 100 is equal to 3. Therefore, expectation of W to the power 4 is equal to 300. So either of C or D is the answer. Now we are required to find the kurtosis of W, right? So kurtosis will be how much? Kurtosis is 3 only, right? Because the excess kurtosis of a normal distribution is 0. So obviously then this kurtosis has to be 3, that we have anyways assumed. So this is how we solve this problem. Now let us go to the fifth question. What is the skew? So I mean, again, this is very simple question. This is just I have put it for a practice. First we have to find the mu. Mu is equal to 90 into 0.4 plus 100 into 0.5 plus 110 into 0.1. Then what we will do? We will do sigma square. Sigma square is what? Now this is how much? This is, I think, 97. Now 90 into 36 and 50 is 36 and 50 86 and 11 97. Correct. So sigma square we have to find out. So this is how much? Now 90 x minus 90 minus 97 square. Okay, we can directly do this. Expectation of x minus expectation of x whole cube by sigma square to the power 3 by 2. Okay, so now for sigma what we will do? 90 minus 97. So this is first step. Second step is 90 minus 97 whole square into 0.4 plus 100 minus 97 whole square into 0.5. Like that we calculate. Now once we get the sigma square, we will do this expectation of x minus expectation of x whole cube. So we have the mu here. So we will do 90 minus 97 to the power 3 into 0.4, like that, and we will divide it by, we got the sigma square here, so we will do sigma square and we will do to the power 3 by 2. Then only it becomes sigma to the power 3, no? So in our calculator we just have to put in the sigma square value and then put y to the power x, and in next key put 1.5. We'll get the answer. And now the final question of skewness kurtosis. See, we have tried to cover some of the types of questions that have come earlier in the FRM exams and that we expect to come in the subsequent future exams also. So all the questions will be some variation or some flavors of these types only. Skewness and kurtosis is a very important topic. Okay. Now let's see what they are saying here. An analyst gathers information about the return distribution for two portfolios, portfolio A and B. Here the skewness is 0.9 and kurtosis is 3.7. This shows a skewness of 1.3 and a kurtosis of 2.1. Portfolio A is more peaked and the portfolio B has a long right tail. So let us analyze the first part. Portfolio A is more peaked. I think this is pretty obvious. Degree of peakedness is kurtosis. So here 3.7 and this is 2.1. So this so far so good. Now, and portfolio B has a long right tail, obviously, because it is right skewed here. It is 1.3. So it will be something like this. So this analyst is correct about both the portfolios. This is our answer. So with this we complete the skewness and kurtosis part. We have few other things also in this chapter like quantiles, means, variance, and some other edge use cases also. So we will cover that during our next classes. Thanks a lot for your time and attention. We'll be back soon. Bye.